Now we are going to sketch the curve of r equals cosine 2 theta in the polar coordinate system. And for this one also, as we did in the previous as we did for the previous problem, we convert everything into Cartesian coordinate system, and then we are trying to plot the curve of r equals cosine 2 theta in the Cartesian system. Now I explained this in detail in the previous video, so I would highly recommend you to go over the previous video where we drew the curve of r equals 1 plus sine theta, and then come back to this one. Okay, right. So here what we do is we again convert everything into Cartesian system, and this is the way we do it. And then here in the Cartesian system, if we now in order to draw the graph of r equals cosine 2 theta, first we draw this one, r equals cosine theta, and then from this graph we are trying to extract out the curve of r equals cosine 2 theta. And keep in mind that this is a Cartesian plane, right? Not the polar coordinate system. And now we need to find the graph of r equals cosine 2 theta by looking at this one. Now this is a very standard curve that you have to have in mind, the graph of cosine theta as well as the graph of sine theta. The only difference is it's like both sine theta and cosine theta will follow a same oscillating nature, but the starting points are different, right? So for the cosine theta, it starts at 1 when the theta value is 0, and for the sine theta curve, it starts at 0 when theta is equal to 0. Right, so how are we going to extract out the graph of cosine 2 theta? By looking at this. So now we just have to look for these important landmarks and then get the complete the remaining portions, because no matter whether it is cosine 2 theta or cosine theta, the curve will still follow the same oscillating pattern, right? But these points might change, right? Now say for example, if theta is equal to 0, right, when theta is equal to 0, then when you substitute it in here, r will be anyway equal to cos 0, and that is equal to 1. So this starting point will not change, right? So here in the curve of cosine theta as well as in the cosine 2 theta, the starting point is the same. And how about now here, pi over 4, that is 45 degrees, will lie somewhere here. Remember, cosine 45 is 1 over root 2, so it is somewhere here. But for this curve, when theta is pi over 4, then r will be equal to cosine 2 times pi over 4, because we have cosine 2 theta, and that is equal to cosine pi over 2, right? And you can see that at pi over 2, you should get the cosine value to be equal to 0, right? So at pi over 2, the curve will reach, pi over 4, the curve of cosine 2 theta will reach 0, right? Now here, this is the cosine theta curve, right? So the angle, the total angle you have here is represented in the x-axis, and if the total angle is pi by 2, then the whole value of cosine theta should go to 0, should be equal to 0, right? So here when the angle is pi over 4, this whole thing will become pi over 2, and at pi over 2, this cosine term will reach 0, right? So here pi over 4 will correspond to this now 0 value, right? And then now definitely it will follow this same pattern, right? So now that means after this point it cannot go upwards like this, right? It should definitely follow the same oscillating pattern like this. But see here the difference is at cosine theta the graph reached 0 at pi over 2, but at cosine 2 theta the graph reached 0 at pi over 4. Similarly, all the other points will change, right? Now say for example, now we know that the curve will have a very similar shape, right? But still now you can see at let's take pi over 2, right? When theta is equal to pi over 2, then r will be equal, now this is the r axis and this is the theta, or in other words you can say this is x and this is y, right? This is, and then r will be equal to cosine 2 times pi over 2 because of this one, that means cosine pi, right? And from this above graph you can see that when the theta value, the total angle in here, when it is pi, then cosine theta should reach -1, right? That means here for the cosine 2 theta curve, when theta is pi over 2, this whole thing will be pi, therefore cosine theta should reach -1. That means here at pi over 2 the curve should reach -1. And there's one more thing that I didn't specifically mention in the previous video. Now since we target for the polar coordinate, target for the curve in the polar coordinate system, we only need the values starting for the theta values starting from 0 up to 2 pi, right? So we just need all the values up to the 2 pi point, okay, right? And so here basically what we need is we need to evaluate points up to theta equals pi, right? No, sorry, well, you cannot say it like that, okay? Now here for this graph also you should get values up from starting from 0 up to 2 pi, right? And it is true that when theta is equal to 2 pi, r will be equal to cosine 4 pi, but this is not the angle that we are considering when we draw the polar curve, right? So the polar coordinate with respect to this equation will starts at theta equals 0. So there we are referring to this angle, not the total thing, right? When theta is equal to something, we obtain the value of r by multiplying that theta with a certain value and obtaining the cosine value, right? So here also, although at theta equals pi, although cosine angle will reach 2 pi, we are not going to stop at this point, okay? We are not going to stop at this point. We have to evaluate all the values until we reach theta equals 2 pi, right? Then accordingly we will be doing the calculation inside, right? And as we know the curve of this original graph, by looking at this one we can extract out the suitable values, right? And now here we found that at pi over 2 it reaches -1, and you can see when theta is equal to, let's have 3 pi by 4, then cosine 2 theta value will be equal to this is cosine 3 pi by 2, right? And then at 3 pi by 2 you can see that the cosine curve will reach 0 once again. That means when theta is equal to 3 pi by 4, this 2 times theta will be 3 pi by 2, which will give the cosine value to be equal to 0, right? So likewise, by comparing this graph, by taking this graph as the basic fundamental stage, we can construct the complete graph for this one from theta equals 0 to theta equals 2 pi. And when you do so, you will get a graph like this with the same oscillating pattern, but these points are different to the one you have for the r equals cosine theta. So this is the curve of r equals cosine 2 theta drawn in the Cartesian plane. Okay, and remember, our main objective is to draw this curve in the polar coordinate system, right? Now we should try to draw the same equation in the polar coordinate system. Now remember, this is, although we represent this as r and theta, this is just the y-axis and this is just the x-axis in the Cartesian plane, right? And now we should try to draw the polar coordinates starting from this. Now in the polar coordinate we don't have those x and y axis, we just have the pole and this straight line, right? So starting from this straight line we should measure the angles, right? Okay, let's see how it goes. When theta is equal to 0, right? When theta is equal to 0, that means when it lies on this straight line, the value of r should be equal to 1, right? So the value of r should be equal to 1, right? And then the value of r should be equal to 1 means this distance should be equal to 1 unit when theta is equal to 0. So this is a point in the curve of r equals cosine 2 theta, and we represent that point by the radius and the angle, right? So now this is not a coordinate in the Cartesian system, right? This is a coordinate in the polar system, right? This represents the value of r and this represents the value of theta. Now you should not mix these things up, right? Okay, and then when it is pi by 4, r should go to 0, right? Now let's have another point somewhere here. Now that says when theta, now here it says when theta increases from 0 like this, right, up to pi by 4. So now to make it easier, I am drawing these dotted lines, right? But remember, these lines do not exist in the polar coordinate system, right? In the Cartesian system, this sort of a vertical line do exist because of the y-axis, but in the polar system they do not. I am just drawing these things because then it will be easy to mark the angles, right? Now let's say this is equal. Now let's have this angle to be equal to 90, and let's say this is the half of 90, which is the line of pi by 4, right? Then that, now here it says when it reaches pi by 4, so you have a straight line like this, and angle increases means this straight line should rise up, right? But it should not maintain the same radius, right? The radius should decrease from 1 to 0, right? So starting from here, it should decrease the radius up to 0, right? Now you can see that all these points, if you take each and every point in this region, right, each and every point in this region, and if you take the radius to that point, then you can see the radius decreases, but still the angle increases. Okay, so the theta value will increase, but the radius will decrease. So this portion in the Cartesian system is represented by this portion in the polar system. And how about the other part? Here it says when theta goes from pi by 4 to pi by 2, that means when theta rises from pi by 4 to pi by 2, that means for the values in this region, right? Now say for example a point in here might have a certain radius which is less than 1 and a certain angle which is greater than 0 but less than pi by 4, and a point somewhere here will have an angle which is greater than pi by 4, and let's see what will happen to the r. R will take a negative value. Remember, when I say a negative r, that represents the opposite point. Now for example, if we have a certain point in here with a radius 3 and let's say an angle of something greater than 45 and less than, let's say, pi by 3, which is 60 degrees, right? And if it is negative 3 and positive pi by 3, then that means you should get the right opposite point to this one, right? You should have the same this point is the originating point of this one, but only difference you have to have is the radius representation. So to do that, what you should do is you should get the opposite of this point. Now I explained this one in a more clear manner in a previous video when I introduced you to the polar coordinate system. So if you are confused with this notation, please go back and refer to that video and come here once again, right? Because I am not going to explain all these things in detail in this video, right? So now accordingly it says when the theta is increasing from pi by 4 to pi by 2, you will be getting a negative radius. So that means although when theta is greater than pi by 4 and less than pi by 2, although the natural intuition is to have points in here, from this graph we can see that it actually calls for the points in this region, right? And to make everything clear, I will draw some more dotted lines, but be careful, these do not exist in the actual polar coordinate system, right? Okay, so anyway, now for the points in here corresponds directly to the points in this region. So what we will have is a certain curve like this, right? Now see here, when theta is equal to pi by 2, what should be the value? When theta is equal to pi by 2, the value of r will be equal to -1. So first plot the 1 pi by 2 point, which is in here with the radius 1 pi by 2 point, and then because it is a negative radius, we will take the right opposite point. So this is the first portion and this becomes the second portion. And how about the rest? When theta increases from pi by 2 to 3 pi by 2, that means from here to here, then also you will have a negative radius values. That means you will be getting points in this region, right? And it will eventually at pi by 3, the radius should be 0, right? So with the negative radius, you will be having this portion, right? This is the third portion and this is the third region. This is the second region and this is the first region, right? Okay, and for this portion, how about that? When theta increases from 3 pi by 4 to pi, that means from here to here, the radius will positively increase from 0 to 1, right? So for the points in here, the radius will increase from 0 to 1 like this. And then for the points in here, the radius will decrease from 1 to 0 positively, and the angles will be from pi to 5 pi by 4. This is the 5 pi by 4 angle, and the radius will decrease like this, right? So this is the fourth portion and this is the fifth portion, right? And then for the angles in this portion, from 5 pi by 4 to 3 pi by 2. So this is the 3 pi by 2 angle, right? And a point in here, right, will have if we just mark a point, naturally the radius will take positive values, right? It will have an angle which is greater than 5 pi by 4 and less than 3 pi by 2, right? And if you get the negative radius, then that point will move towards this region. So what you get is something like this, right? This is the sixth region. And then similarly for this one, you will actually have points in here, but since the radius is negative, it will be pushed towards this region and have something like this, right? And then again you can complete the final portion, 8, from 7 pi by 4 to 2 pi. That means for this region, 7 pi by 4 to this region. Now remember, we are comparing a graph in the Cartesian plane along with this polar coordinate system, right? Up to 2 when theta reaches, so here when theta reaches 2 pi, you should have a radius of 1, and in this region you have a positive radius. So we are not going to invert the points or anything like that. So here it will complete this section. So ultimately what you will have is a very nice curve like this, but that's not the way it started, right? Now we had a curve like this and it was something sorry, we had a curve like this, and then we had it like this, and then we completed this portion, and after that we completed this one, and then we finally completed this one, right? And this is called the four leaved rows, right? So if you draw it correctly, you can see that all these portions are symmetric. It's like a petal, I mean these are like petals of a rose flower, right? That's why you call it as a four-leaved rose. And also I forgot to mention, now in the previous video we described the curve of this one, and it is like a inverted heart, right? So it's like this, and this is called a cardioid, right? Cardioid, right? It's like kind of a inverted heart, so it's cool to remember those names as well.